Next approach is numerical approach, where we use governing equations which are formed from the real life experience. Okay, so many people ask whether even if you do research using the numerical methods, using the governing equation, whether it is research. Yes, it is also research. It is also considered as empirical because the equations are based on the real life experience. Okay, so when we do numerical analysis, no, it is little difficult to publish the papers as compared to the experimental. Okay, so as the science and engineering are advancing, and we not limit ourselves to the single approach. You should at least use two approaches, maybe experimental and numerical, major work experimental, minor numerical, or major numerical and minor experimental, like this. So we have to cross check. Please understand, whatever we do, we should cross check. Okay, that is very much important. So when you are using experiment, we should cross check with the numerical. When we do numerical, we should cross check with the experimental, like this. Now, please understand, you are new to this field, and whatever I am telling, sometimes it may be very much mathematical or related to mechanical, but please understand it is applicable to majority of the fields. Okay, so don't worry about the complexity. If you find very much complexity, I will try to make simple notes for you. So you just mention me, like uncertainty analysis, you may find it difficult, but I will give the separate PPT for uncertainty analysis, and I will try to uh, give as much as possible all the steps, so that I will not skip any steps, so that if you solving yourself, you will understand. Okay. Now there are tools in the experimental approach. One tool that we generally use in the heat transfer and fluid mechanics, that is a dimensional analysis. So we'll understand what is the importance of dimensional analysis. Okay. Suppose in your analysis, there are 5 parameters. Okay. So when we deal with this 5 parameter, you need so many variations. Okay. So many variations that it will be difficult to conduct. So instead of 5, if I reduce this parameter to less parameter, then your number of readings get reduced. Okay. So if you want to reduce the number of variables in your research, so how we reduce this number of parameters or variables in the research is by using the dimensional analysis. So there was scientist Buckingham. We gave the theorem called as Buckingham-Pi theorem. So here we can reduce the number of independent variable to the dimensionless number. So generally, suppose we have 5 variables, independent variable, then we can convert to the 3 we can say independent dimensionless group. So number of the parameters that we vary get reduced. Okay, so our experimental work get reduced. Otherwise, it will become very hectic. Okay, so number of independent dimensionless parameter that we form from the n variable will become n minus r. Okay, suppose there are 5 variables and basic dimensions like mass, length, time, like this. But suppose basic dimension is 3, then we get only 2 variables. Okay, so we need to vary only 2 variable, that is called as what? Dimensionless parameter. Okay, only vary the 2 dimensionless parameter. Okay, I have given now here one example. Like there is one phenomenon, natural convection. In that there are 8 independent parameters. There are 8 independent parameters. Okay. And there are 4 basic dimensions like mass, time, temperature, and length. So we have to only remember this. That is the number of variable minus number of basic variable, basic dimensions. Okay, so 8 minus 4 will become 4. So we get 4 parameters. Okay, like these are the parameters. And from that we get a 4-dimensionless group. Okay, so we need to vary one dimensional group at a time. Okay, are you getting the purpose of dimensionless analysis? It reduces the number of variables. Okay, it reduces number of variable. That's why time for conducting the experiment, money required for conducting the experiment get reduced. Okay. Now, there comes also the quality assurance for numerical methods. We use, like, we have to do verification, validation. Validation means what we do? We compare with the reality. Like numerical, we do in the software. Okay, so we compare with the reality, that is called as validation. And verification means what we are doing, whether we are doing or not, that we check. Like, suppose I want 1 meter per second velocity, whether in the software it is correctly put or not. Okay. Then we see the gradient dependence. We see the number of, we can say, cells we have taken. We check with the different turbulence model. We do the sensitive analysis. Okay. Like this we do for numerical. Okay. The for numerical study, I will give an example of CFD, but similar will be in your case. Okay. Now, whenever we do any activity, we measure the productivity, whether we are getting right output or not. Same thing for the research. We also measure the productivity, scientific productivity. Like for scientific productivity, suppose we are having some research center and we want to measure the output. So what will be input for our things will be scientist, will be infrastructure building, then equipments, then mobile internet, their salaries. What we expect from this, we need to expect research papers, patents, books, technology transfer, instrument design, royalty earn. Like other field, also we measure the output of the research and we give this much parameter, patents, research paper, then royalty earned from the patents, technology transfer. Now, when we say something about the research, when we say about productivity, we have to also pay attention to the parameters that affect the productivity of the research, like the environment, resources. Like environment, if suppose in your institute, suppose you are working as a teacher, the environment is encouraging you, providing some allotted time for your research, then you can finish your research fast. But the environment is like that, you are continuously busy or no one is encouraging you to do the research, that will be negative atmosphere. Okay. Then comes resources. If you have a good library, a general subscription in your institute, so it is a type of the resource. Then instruments needed for the experiment, This comes the resources, and then obviously if the resources are available, you can do good research and can publish the papers. Availability of mentors. Please understand that even the researchers needs mentor. Okay, if there are good mentors, there will be good outcome in terms of patents, the research paper. Then the age of the researcher, it matters. Okay, the young people will be more dynamic, interested. Aged people, in spite of having good experience, maybe slow. Okay. Also, experience matters in doing the research. Sometime maybe in experience, person can cross the limit and can achieve the better thing. Sometimes the experience may be negative and gives you a particular feeling about particular area. Okay. Then number of researchers involved in the project. If there are more researchers, we can get outcome easily. Okay, but if too many can affect your research. And then comes mobility of researcher in search of better prospect. Same thing like industry, researcher may also change the job. When he changes the job, it will affect the project, research project. Okay, so mobility also affect the research. Then avenues for individual growth. If there is a growth after doing the research or completing the project, it will productivity will increase fast. Like in an age when private and government bodies are asked to award large sum to scientists for research activities, okay? Those in charge of making such decisions feel uneasy about having to base their decision only on guess and on the personal experiences of previous science administrator. In true scientific spirit, these decision makers would like to have more objective knowledge and understanding of human activities in order to improve the efficiency and impact of their operations. Okay. So we'll see why we need evaluation of productivity. So scientists, whether it is private or government, please understand one thing that research needs money. Okay. And when any organization is investing money, whether it is government or private, it wants output from this. Okay. So when we want output, then we also want to measure the performance from the scientist. Okay. So how we measure the performance? We measure in the two ways, quantitative analysis, then qualitative. Okay. In the quantitative analysis, we see how many papers are published by given scientist, number of scientific publications. Then we do the two ways evaluation. Please understand. One is quantitative, one is qualitative. In quantitative, we see the numbers, like how many research papers are published, how many patents are filed, how many technology transfers are done. Okay. But sometimes numbers may not give the proper idea. So what we have to do is we have to also check for quality. Okay. So we have to review the papers and judge this rating, whether it is a very high quality paper or medium quality or low quality. Then also citation analysis. How many others have referred your paper for writing his or her paper? So that is citation analysis is also important. So like when people think that research is something that we have to go on thinking and thinking, and there is no particular outcome, but it is not like that. So there is a way to assess, to evaluate the performance of the scientist or researcher. So we already seen what are the ways we can see the performance, productivity, like the scientific paper, patents, technology transfer, and if you want to go in detail, we may go for quantitative analysis, but further, if you want to go for qualitative analysis, then we have to also see what is the rank, whether it is good quality, medium quality, or low quality research paper. So, and these are my references. So I will suggest you, if your library is having this book, Experimental Methods for Engineers, it is by Holman, okay, by Tata McGraw-Hill. Here we can use this uncertainty analysis. So I have taken the examples from this book. Also, statistical analysis I will take from this book. There is one more book, Paneerselvam, Research Methodology. Then I have used some notes from online. Then for heat transfer, I have used this book, R.C. Sachdeva. Okay. So if you have any doubt, you can ask. Though one thing you may experience is the uncertainty analysis you may find difficult, but it is required, and we will solve a few problems. So I will give sample problem, and I will also give the unsolved problems. Okay. So you can practice. So if you have any question, you can ask me. If you have any question, you can ask me.